All right, so in this equation, we're going to solve by another method called reduction of order because as you notice, this one is a second order equation, but through a substitution, we can convert it to a first order equation. So we're reducing the order of the differential equation. So I'm going to let u equal to y prime, and then that means that u prime is equal to y double prime. And we do this just to basically make it look more familiar. So this means we have the differential equation u prime minus 2u is equal to 5e to the negative x. And again, we left the right-hand side untouched, so we don't write anything differently there. So at this point, this looks like a first-order linear differential equation. So we're going to find the integrating factor, which we know is e to the integral of the coefficient of u. And the independent variable is still x. So this is e to the negative 2x. So this means that I times u is equal to the integral of I times q, and x is the independent variable. So we have e to the negative 2x times u is equal to the integral of e to the negative 2x times the original function on the right-hand side, which is 5e to the negative x. And we know we can simplify that by laws of exponents. This is 5e to the negative 3x, which we know has antiderivative negative 5/3 e to the negative 3x. And don't forget the plus c. And that's all equal to e to the negative 2x times u. So solving for u, we multiply both sides by e to the negative 2x. That's negative 5/3 e to the negative, what's negative 3 plus 2, so that's negative 1x, and then plus ce to the 2x. Now we're almost done, but remember, u was equal to y prime. So that means we have y prime is equal to negative 5/3 e to the negative x plus ce to the 2x. So in order to get y, we have to integrate this. So just writing all this out. And remember that constant is there. So we're going to end up with another one. So integrating, so negative 5/3 e to the negative x, integrate e to the negative x, you get negative e to the negative x. So that's 5/3 e to the negative x. The negatives cross each other out. And we could say 1/2 c e to the 2x. And then there's even another arbitrary constant when you integrate. So this one has two arbitrary constants. Now, we can rewrite this as, I'm just going to call this whole thing C2 because half of a constant is still a constant. And what that basically tells me is that my solution has the form 5/3 e to the negative x. I know I'm sounding like a broken record at this point. Plus some number times e to the 2x plus some number. Okay. And that tells us that since this was a second order differential equation, we should expect two arbitrary constants. And that's one thing we're going to learn as we go through, is that third order differential equation will have three arbitrary constants. First order differential equation had one arbitrary constant in the solution. So this is just something that's leading us to another pattern. So there's your example of reduction of order. We will be having a larger discussion about second order equations that can't be solved by reduction of order later on in the course. So stay tuned. Thanks for watching.